While performing a routine code auditing, our team has discovered several vulnerabilities in Ncurses present on multiple operating systems. In this talk, we will discuss those vulnerabilities and the dangers they pose, as well as discuss open open source software security in general. JBO is from DefCon Group 9723 in Tel Aviv, Israel. Uh, he is a principal security researcher at Microsoft, working as the mic at the. These instructions for my lips were in Chinese, and I don't read Chinese. So, working as the Microsoft Defender Research Architect for cross-platform, Jonathan has rich experience in vulnerability research, exploitation, cryptanalysis, and offensive security in general. So, welcome to the stage, JBO.
Hooray, thank you. I hope I'm audible. Um,
We can hear you.
Awesome. For the folks that are in this room, the physical room, just try to keep it down because it's hard for me to. Thank you, I appreciate it. Giglio, this is the curse of Ncurses. Giglio, please continue to the next slide. And I'm going to zoom in here. Okay, a bit about me. My name is Jonathan or JBO for short. My Twitter or X handle, depending on your point of view and preferences, is JBO. I write here and there stuff. As X-Ray mentioned, I'm a member of 9723, the Tel Aviv Israeli one. But in the last 6 years, I've been I've relocated to the US and I've been living in a suburb of Seattle. But that's pretty much about me. I'm a Microsoft Defender for Endpoint Research Architect that is focusing on stuff that usually do not run Windows, which is Linux, macOS, iOS, Android, Chrome OS, IoT here and there, Windows here and there, especially in the last couple of years with Windows having WSL, WSA. If you're unfamiliar, Windows cannot run Android. So everything is now a mishmash and you need to know everything to do everything. So that's what I'm trying to do. I have a mix of offensive and defensive security. I'm also, before having a kid, I used to have a lot of hobbies, but now my hobbies are sleeping and eating in that order. I'm a husband, a father, a cat lover, and that's pretty much about me. Next slide, please. I don't see the slide moving. Giglio? Okay, good. There is probably some lag. And this talk is a research that we have done, not just me, but a few other folks. The first folks here, Emmanuel, Michael, Alexia, and Dan are Microsoft researchers. And interestingly enough, we also collaborated with Gergely Kalman, who I probably butchered his name now. He's not a Microsoft employee. We just reached out over Twitter, or X, which was pretty interesting, in terms of collaboration between us and folks who are not Microsoft employees. So shout outs to them. Next slide, please. Okay, how did it really start? How did this research start? So if you're familiar a bit with POSIX or Linux or Mac, whatever, then you probably know about sudo binaries. This is how sudo works. Basically, it has a flag in the file system that says if I have this flag, then whenever someone runs me, it's going to run as my owner. Usually, it's for root, right? Usually, root would be the owner, and this is how sudo binaries work. This is how you elevate privileges legitimately in Linux and other POSIX file systems, other POSIX operating systems. And we were looking, or I was looking at macOS sudo binaries because Linux sudo binaries are very secure. They're not, but I mean, folks have been looking around, and I mean, a lot has been found. And I was asking myself, well, does macOS have the same kind of scrutiny? And I don't think it does. So I started looking at macOS sudo binaries, and I noticed top is a sudo binary. Now, top, if you're unfamiliar with the utility, It's like a task manager for like a QUI, which is like the console UI kind of thing. It shows you all the tasks and everything. And it's very surprising to see that top is a suite binary in Mac OS, which is different from top on Linux. And there are reasons for why it's a suite binary. Basically, it needs to get something on Mac OS that's called like a task port, which is the equivalent of a process handle in Windows, and you need like certain privileges and capabilities to do that in Mac. In Linux, not so much. You just run ptrace and you're good. Or in Linux, it's actually different. You have procfs. In Mac, you don't have that. And because of that, Apple has basically changed how top works. It still shows all the processes and whatnot, but it's much less capable. So they changed the code there and made it like a suite binary, which is interesting. And then I was like, okay, it doesn't look like I can run child processes and stuff from top on Mac. But I was like, what are the dependencies that top has? And I, in the screen here, in the bottom part, you can see top is owned by root, and it has in the privileges, you can see r-s and then r-x, r-x. And the S part in the r-s means that it's a suite binary, meaning that if someone runs it, it will run as root, which is very interesting. If you run otool-l, which is the Mac OS equivalent of readelf to basically parse the macho files, it will show you the dependencies. And if you can see one of the dependencies, say, there are many interesting dependencies here, including Core Foundation, which is a Mac OS thing. And one of the dependencies, the third one specifically, says lib ncurses find 5.4. Now I started looking and I'm like, okay, Ncurses, like when I started doing this research, Ncurses was at 6.4. So 5.4 is pretty fucking old. So pretty interesting, to look at that and see what we can achieve. So that was the, I guess, incentive. Next slide, please. What is Ncurses? What is that thing? Ncurses is an open source library dating back to 1993, so pretty old. Sorry for you all this online or in the room, but like 1993, in my opinion, is still old. Geez, 30 years ago. And it's responsible for TUI handling, like terminal-based UI, just like Top does. It's used by several binaries on both Linux and Mac OS, and actually more operating systems. It's coded in C, which is good and bad, depending on your preference and point of view. And it has a very, very complex logic. Now, you might ask yourself, why does it have a very complex logic? All it has to do is like print nice things on the screen, right? So here's the thing. Ncurses is the successor to Curses, which happened in 1980, and Pcurses, which is another library that happened in 1982. And interestingly enough, it's maintained mostly by a single person who does not get any money out of it. Just like Log4j, for instance, who was maintained or still is maintained, I don't know, by 3 folks in an open source fashion. So same thing, but only one person who is a real superhero, actually. If you see the name Thomas E. Dickey, he is the maintainer of Ncurses, and he's the maintainer of other big projects. The biggest project that I've seen that he maintains is Lynx, which is, again, another UI-based, in this case, browser. You can actually use a browser in your terminal, but you can't do nice things with it, like log into DCG VR. So don't use that for that, because there's no like video and stuff. But it's really interesting, and his code is really, really interesting. Thomas is doing all of that without getting paid, as far as I know. So why is the logic really that complex? And the reason for that is because terminals are really, 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 really complicated and hard. Next slide, please. Okay. So if you remember, if you're really, really like into old stuff, or you've been around, you remember the old days when terminals were actual terminals. Like these days, if you have a terminal, it's a pseudo terminal. It's not a real terminal. I'm talking about like a physical thing, right? And terminals are complicated because they have different makers, they have different capabilities. For instance, I mean, can you do a backspace, right? You can imagine that those terminals are like teletype and stuff like that, where you can't obviously do a backspace. Some of them didn't support colors and so on and so forth, right? So there are many different makers, different terminals, and of course, there is no like a uniform standard for anything because it's the 1980s and everyone, you know, basically had no standards. Well, just like today, but I mean less like today. Um, so the question is, how can you be if you're going to write a Ncurses library, Ncurses library, how can you be terminal independent, right? Because you have like it doesn't make sense to write code to each and every terminal. So what was done is basically to have something called a terminal info database, and that thing kind of specifies the capabilities of different terminals. So a terminal of maker X can support backspace, or terminal of maker Y has 25 columns and 80 rows, or the other way around. So that's the motivation. So those terminal info database files can be viewed with the info CMP command. That's both on Linux and Mac, and I think most POSIX systems have this kind of tool. And interestingly enough, terminal info databases are an advanced version of a really old format called termcap, which is a 16-bit thing. It's as you can probably imagine from 16-bit, it's really old, and I won't be discussing it here. It's rarely used these days by anyone. Next slide, please. This is an example of me running info CMP. The -1 basically is not interesting. It just means that it's going to like show one line by line. It doesn't really matter. And I just show the first 10 because there are tons of them. As you can see, this basically translates the current, in this case, terminal info file into a textual format. I'm kind of hinting right now that the terminal info files are really binary files, which they are. And so the first part is a remark that says reconstructed via info CMP from file whatever. And you can see here the name of the file. This is the term info database file that is being used for the current pseudo terminal, which is xterm in this case. And then you can see a bunch of letters which look weird, like AM, BCE, CCC, KM, and so on. And some of them look like swear words, but they're like most of them are not. If you run the file command on the terminal info file, you can see that it says compiled 32-bit term info entry, whatever, which is really interesting. It's compiled, it's binary, and so on. So very juicy things, in my opinion, at least. Next slide, please. There is a major lag between Giglio hitting the space and me seeing the thing, but it's fine. So what are the capabilities like this AM and whatnot that you've seen are basically capabilities of the terminal. And apparently there are 3 types of capabilities. There are Boolean capabilities, numeric ones, and string ones. So Boolean capabilities are basically there or they're not there. For instance, we've seen AM. AM basically means whether the terminal supports something called automatic margins, which I don't care a lot about, but that's a thing. Numeric ones basically mention numeric values. For instance, calls pound 80 means that the terminal supports 80 columns. That's the meaning of calls pound 80. And you can differentiate, of course, the different types of capabilities based on how they're represented in info CMP. Boolean ones will just have the name or not. Numeric ones will have the name and then a pound, which is the uniform, like universal sign of a number and then a number. And then the string ones will have an equal sign. In this case, I show you clear equals /e and then bracket h, and this looks like another swear word. And these are really the control characters for cleaning the screen, which is really interesting. And this is how you basically are going to be terminal agnostic. You basically are going to use those term info files to send certain control characters, or you can at least know that you support certain amount of columns or Boolean values and so on. So I hope the motivation is clear. Next slide, please. Oh, that's good. String capabilities, like out of these three, if you were looking for vulnerabilities, obviously you would look at string capabilities. Why? Because they have like the most amount of input. More input equals more vulnerabilities generally. String capabilities are complex because they might hold more than simple string literals. Apparently, they support something which are stack-based operations on parameters, which sounds very, very juicy. Eventually, I discovered, and I will show you later, that string capabilities are just like programming. They're not Turing complete, but they're very, very close to it, which is really interesting. For example, string capabilities are used if you want to move your cursor. If you want to move your cursor from, let's say, the current position to, I don't know, 5, 7, then Ncurses will use mvcur command, the mvcur capability really, which ultimately uses cap capability with the x and y sent as parameters. So it's pretty interesting. The term info files, the string capabilities, at least in them, can get parameters from the program, in this case, Ncurses, right? So Ncurses sends as the first parameter, let's say 5 or the x coordinate, and the second parameter, the y coordinate, and uses the cap capability, which will use those parameters on a stack, which is not really a stack. I'll show you how it looks like, to eventually send some control characters or do something. And that's pretty much it. The capability interpreter is really some sort of bizarre programming language. That's pretty much what I said. Next slide, please. All right. Still waiting for it to be loaded. Man. So these are the stack-based string capabilities. This is not a complete list, but these are just a part of the things that you can do, right? If you write your own term info database file, obviously. So for instance, you can do percent and then a number between brackets, which will push the literal number to the stack. You can use the P1 until P9, which are the parameters that were being sent. If you remember, the moving your cursor thing, that's pretty much it. And it will use P1 and P2 as parameters. You can add, subtract, multiply, divide, or take a modulus, sorry, to perform arithmetic operations on numbers. Basically, what it does is to pop two numbers from the stack, calculate something, and then push it back, which is really interesting. You can do the same thing with comparison operations, like are those equal? Is this less than or bigger than? And you can even do a bitwise AND and a bitwise OR and push the result back to that stack. You can pop a string from the stack and push the string length back to the stack. You can even have conditions, which is extremely interesting and useful if you are into programming even. Which you can basically write a condition and then a body and then another body. In this case, it's like a question mark condition and then a %t, which stands for then, and then a body, and then %e, which is for else. The else part is actually non-mandatory. Besides that, you can pop a string from the stack and print it to the screen with %s or %c, just like you do in a printf, let's say. And you can do that with numbers too, with %d and %x. Again, just printf or scanf style. So there are a lot of different interesting string capabilities that you can use as an attacker or someone who writes like a term info file if you're really unlucky and chose the wrong profession in the world. Next slide, please. Why do I care? So some interesting motivation. This is from the man page. The man page is extremely long for term info. And one of the things that I noticed is that it says, and that's in red, if there is an environment variable called term info, then basically the path name is going to be used from that environment variable instead of using the correct term info database path, right? So I can basically, if you think about it, I can really create or poison a new database info file, which is really juicy if it's going to be used by a suite binary. right? That's the motivation. Even if that environment variable is not set, Ncurses will actually look at your home directory and then a .term info directory, which you can plant like plenty of term info files there. Only after it didn't find the environment variable and didn't find the term info directory will it actually, there is another environment variable called term info dirs, and if all of them like are not there, then it has basically a way to like a search order in other paths, the legitimate paths, let's call it like that. So this is the motivation. Next slide, please. And this is how it looks like, a little fun experiment if you care about those things. This is an example of environment variable poisoning to do something fun. I use info cmp-1. I remove the clear command and write it to a file called cur, which is just a file, it's a text file. I add a new line in there that basically says clear equals lol hacks, and then a line break, and add it to cur. This basically means that instead of sending like the control characters for cleaning the screen, I can do something else. Then I use a tool called tick, which is the terminal info compiler. That's what tick stands for. It's really funny, actually. They have 3 tool names, tick, tack, and toe. I don't know why. And you can do -o on cur and -o on the current directory and then cur. And then I can show you the files. I use ls-la, and you see that next to cur, there is a new directory called 78. On Linux, it will look a bit different. It will create probably like the first name in the term info, in the pseudo terminal name, so probably starts with an X for xterm or something, but it's the same concept. Now, if I use term info equals the current directory in OpenSH, it will use that my term info file instead of the normal term info file. And when I try to clear the screen with clear, it doesn't clear the screen, just writes lol hacks, which is like really interesting if you want to like mess around with those things. Next slide. And environment variable poisoning can even be done more interesting. You can, if you remember, again, I mentioned that top is a suite binary in Mac. Well, in this case, I created something interesting. I created a, kind of like a malformed term info file. And then if I do term info equals current directory in run top, it actually poisons the environment variables used by top, which is a suite binary, and I cause a segmentation fault or a crash, in other words. Causing a crash in a suite binary is really, really dangerous because it means that you can do like memory corruption on a suite binary, which kind of hints that you can achieve an elevation of privilege, which we eventually have. So that's pretty good. Suite binaries that are not sanitizing the environment are extremely dangerous, and that's a classic local privilege escalation potential. Like if you look around, in even this year, I think you can find on Linux several suite binaries that did not sanitize their environment variables well, and folks were able to achieve local privilege escalation. Next slide. So my question was, is macOS outdated? If you remember, Ncurses, macOS uses Ncurses 5.4, and the current Ncurses is still 6.4, so like one major version above. So interestingly, there have been some public Ncurses vulnerabilities before. We're not the first ones to find vulnerabilities in Ncurses. And Apple uses the old Ncurses, again 5.4, but applies security patches. And you can find that in the Apple OSS distributions GitHub repo under Ncurses. You can see them actually applying the patches, which is really interesting. I don't know why they insist on staying with 5.4 and not taking the latest and greatest. Probably or possibly because they don't want to retest everything. Testing is very hard. That's my only suspicion. I don't know. I never asked, and they never told me anything. So we tried a bunch of public vulnerabilities, and they did not affect the Ncurses on macOS. And that means that we got to find some fresh ones then. And we started by fuzzing and code auditing. Next slide. Awesome. So fuzzing is really, really good when it comes to file parsing and packet parsing. This is like the bread and butter of fuzzing. So terminal info files are binary files. There is heavy C parsing, and that means memory corruptions. We've already been able to demonstrate one. So so the obvious candidate for fuzzing is the file parsing part. We started by fuzzing with AFL++. AFL++ is not awesome when it comes to macOS. It's extremely slow. And while we were fuzzing, I started like taunting online in Twitter when it was still called Twitter, that hey, we're fuzzing Ncurses. And then Gergely Kalman like approached and said, oh, I have a fuzzer that he wrote from scratch and some crash cases too. So he basically gave them to us, and I was like, oh, thank you, sir. So I mean, I owe Gergely at least a beer. This is not a fuzzing talk. We won't go into details. And his crashes were all rooted in the same issue. And we wrote our own fuzzer as well. So while consuming electricity and melting the planet, we also, looked at some of the crash cases and also did like code auditing at the same time by hand, because there are some things that fuzzers don't find for some reasons. Next slide. Discovery number one, that's probably a really good discovery, and it's a heap out-of-bound write. The function that parses term info files fills a structure with different capabilities, the three types. So it'll have like a structure with Boolean types, and then the numeric types, and then the string types for the types of capabilities. And after those in the memory, there is room for something called an extended capabilities, which can also come in three types: Boolean, numeric, and strings. The reason for extended capabilities is that if you wanted to add capabilities that are not standardized, and again, there is no standard, but I mean, let's imagine that there is one. There is a de facto standard for what it's worth. So you can add those things, like you can write JBO equals cool, or whatever you want to do, right? So those are extended capabilities. And specifically, if there are extended strings, a certain memory region is being reallocated, literally with the realloc C function. And that reallocation might actually be reallocated to something smaller than the number of extended strings, the number of non-extended strings. So if the number of extended strings is large and the number of regular strings is small, then we're going to have an out-of-bound write. And I'll show that in the next slide, please. Thank you. That's the issue here. You can see in this case, PTR is basically the struct that I was talking about, and strings is the member there. And you can see that there is an alloc here, basically a calloc. That's a malloc that zeroes out the returned chunk. With a maximum between str count, which is 414 bytes, if I remember correctly, and little str count, which is the real number of the string count. Now, next slide, please. And this is where things go a bit crazy. The number of strings, if there are any extended strings, the current number of strings is basically that maximum number, which is 414, plus the number of extended string counts. And then you can see a realloc of, probably the thing is a bit skewed. The other red box should be around PTR strings. So in line 278, where you see a realloc of the number of strings. And that realloc is problematic because usually when you realloc, you want to realloc to something larger, not something smaller. Because we're reallocating to something smaller, then dereferencing a standard string can actually lead to out of bounds write in the heap. That's the idea. Next slide. That was discovery number one. Discovery number two is even more severe. It's a design issue that we discovered just by code auditing. The function tparm, which simulates the stack-based string operations, does not know how many parameters it expects. If you remember, the string capabilities can actually get parameters between P1 and P9, right? And what it does is to basically push those things to that fake stack, right? As I said, it's all stack-based capabilities. It's a variadric function like printf, so it gets a non-defined number of parameters. The way that a variadric function works is that it doesn't know. It basically pushes all the parameters that were giving to it, and then it is in this case printf's responsibility to know how many parameters to pull from the stack. The same thing happens with tparm, which is a part of Ncurses. The issue here is that it doesn't know how many parameters to pull. In printf, printf does it by actually looking at the number of formats. So for instance, if you do printf %d %s, it knows to pull 2 parameters from the stack because there are 2 parameters that it expects. In tparm, what it does is to look at the maximum number of parameters that is being used by the string capability. So for instance, if you have the maximum number is %p7, then it knows how to pull 7 parameters from the stack. And that's kind of like an information leak straight from the stack. If you have a capability that expects only %p1 and you make it use all the way until %p9, again, the function doesn't know how many parameters to expect, so it basically pulls stuff from the stack without any control. And you can get to pop 8 different values from the stack and use them in various ways. %x is my favorite way. I'll show you a demo, not a real demo, but a screenshot in the next slide. So next slide, please. This is an example of the capability CUP cup, which is used somewhere when moving the cursor. And normally it expects, I think, 1 or 2 parameters. But in this case, what I've done is to override cup equals leak and then %p1 %x. What it does is to push the first parameter and then pop it and print it to the screen hexadecimally, right? Same thing with p2, p3 until p9, right? So basically what I do is to pull stuff from the stack and print it to the screen. And when I run top with that, you can see that it says leak and then a bunch of different values. Those values are values that are pulled from the stack. And this is pretty interesting, not only as an info leak, like basically if there is something interesting on a stack, like, credentials and stuff, you can pull it, but also because it actually defeats ASLR, right? ASLR, if you're unfamiliar, is a defense in depth mitigation that randomizes where libraries are loaded in Linux, and in Linux it's pretty strong. In Mac OS not so much, but the idea is that to defeat ASLR, you basically need to leak information about a certain location of a library. And in this case, some of these values, specifically P4, in this case, is we discovered that it was an actual address somewhere in a fixed offset from the base of a certain module that is loaded to top. So this is a way to defeat ASLR and start building a rob chain if you're familiar with the subject. So that's pretty cool. Next slide. The third issue was a type confusion. If you noticed, we have parameters again, right? Like P1 until P9. The stack-based string capabilities, that's something really interesting. The stack-based string capabilities are not really stack-based. They're really heap-based. And what happens is that there is an array on the heap with 20 frames and the top of the stack index, right? So they didn't really use a stack. They like pull stuff from the stack if they need to, the actual stack, but then push it to like this fake data structure, which they call a stack. And each frame has a type, which is either string or numeric, and a place for data. As you can see here in the screenshot that I gave you, you can see how a stack frame looks like. The first union there, data actually contains the data. The data can be either numeric 32-bit signed integer, which is called num, or it can be a pointer to a string car pointer, right? And that's data. And the num type is basically the kind of the type. If that boolean is true, it means it's numeric. Otherwise, it's a string data. Next slide, please. So for numerical string specific operations, you already know what type you're expecting and what you get. For instance, if you use %+ to add two values, you know that you're expecting to pull two numeric values from the stack and push one numeric value back to the stack. So that's pretty clear. If you use %s, you know that you're expecting to pull a string from the stack and print it to the screen, right? So the question is what happens to parameters like %p1, %p2, and so on. There are certain capabilities like the cursor moving part that are really expecting numeric values, but there are certain capabilities that expect string parameters, and there is no way to know. So apparently what Ncurses does is heuristically conclude the parameter type based on the static scan of the capability. So for instance, if you get a %p1, %s, it kind of says, oh, I see a %s, and that means that the last value that was pushed, which was %p1, is a string. That's how it concludes it. If you do %p1, %x, on the other hand, or %d, it knows, oh, I'm expecting the thing before %x in this case to be a numeric parameter, not a string parameter. So I associate p1 with a number. And then if you remember, one of the cool things that we've done or we've described is conditions. Now, the thing about conditions is that they can be true or not true, and they're resolved dynamically. So heuristically, you can't really conclude anything. So what happens if you do %p1? That means basically if p1 is not equal to 0, and then use p1 as a numeric value. Otherwise, use p1 as a string value. The heuristic here, like, obviously fails because p1 can't be both numeric and string. But you can make basically the heuristic thing think whatever you want it to think. You can make the heuristic check in Ncurses think that p1 is a number or p1 is a string as you wish, right? Because of those conditions that can or can't really happen. Next slide, please. Using the type confusion capability or a type confusion like attack that I've shown, basically how to fool the heuristic check, you can basically make certain capabilities behave very weird. For instance, in this case, what I've done is to show caps equals %p1 %s. Caps really expects the parameter to be a numeric value and not a string value, but because I poisoned the term info file, I make it think that cup is really a string value. What happens then is that, and I attach a debugger here, which is LLDB. If you're coming from a Linux world, you can imagine it's a GDB net, just not as good. And what I've done here is just to show you an interesting crash, where basically I run the thing, and then you can get bad access. And then you can see the address being 10, or hexa 10 really, which is 16. The reason for that is because P1, which had the value 10, because it was pushed on the stack as a numeric value, is being treated as a string. So what really happens is that top, in this case, tries to read from address 10, right? And this is basically like an out of bounds read to an arbitrary address, because you can actually control where the cursor moves if you control top. So I can make top read a treat as a string to any address, which is really a great capability. So that's the discovery number 3. Next slide, please. We had other discoveries too. For instance, we discovered the dereferencing of address -1 always, which is not really interesting, just a denial of service, you can crash whatever, and other minor denial of service crashes. What Gergely has discovered, by the way, was the dereference of address -1, but still pretty cool. And what we discovered is that it's possible to combine everything that we found to get a local privilege escalation on Mac, right? So that's pretty severe. Disclosure was done to Thomas E. Dickey, and it's really interesting because there is no standardization to those things. Like if you find a bug in Mac OS, you report to Apple, right? If you find a bug in in the Linux kernel, you report to kernel.org or directly to Linus. But in this case, it's like a third party library, if you will, that is being used in Mac OS and Linux, and actually OpenBSD and other operating systems as well. So all of the memory corruption issues that we found actually affect all of those operating systems to different degrees and severities. So that's pretty cool. So we disclosed both to Thomas E. Dickey, that's the first person that we disclosed to, and to Apple, and to OSS Security, and the Free Software Foundation, and the police, and the FBI, and whatnot. And to major Linux distributions like Arch Linux, Red Hat, Canonical, etc. It got the CVE 2023 29491. Really, there should be like tens, I think, of CVEs here. But CVEs are not trophies. We don't really care how many CVEs we get. So we were like, just want to like track the issue for like very, very obvious purposes. So that CV basically says something like multiple corruptions in Ncurses or something like that. Fixes are not easy. The fixes are easy, for instance, for the heap corruption vulnerability, the realloc thing that I've shown you. But some of the design issues are really hard to fix. Like how do you know how many parameters to really get? Or the heuristic check is something that you can't really do when you do a static scan of a string because of those conditions, for instance. So it really complicates things. And Thomas E. Dickey worked really hard on getting it fixed, I think in a week and a half, which is really impressive. So huge thanks to Thomas and pushing like the patches and everything. Next slide. I did want to mention that I don't drop 0 days by definition just a week ago. So there was a chance that I'll have to censor some of these slides, but I ended up not doing that because I'm very happy to say that those issues are not just fixed in Ncurses. They went upstream in Linux, and they're also fixed just a week ago by Apple. So that's pretty good to know. It took them a while to actually get those fixed, even though it's just, normally they would just take like the latest version of Ncurses, but probably because of what they do with Ncurses 5.4, they had to apply the patches and then probably have a lot of folks just testing stuff, which is not fun. So shout outs to them as well. And my conclusion or personal conclusion, and I hope it resonates well with you guys, is that the state of open source software and third-party libraries is kind of insane. It's just like a Log4j when you had, again, 3 folks that were just maintaining stuff, not getting paid at all, and everyone was using it. The same thing happens here. Like Apple is using that, Linux is using that, and Linux is not for money, but there are like Red Hat, for instance, actually makes money, right? So all of these guys use just one dude maintaining a library somewhere in his house or whatnot, and it's used across different operating systems in many different scenarios. And I don't know, it reminded me at least of Log4j, not to that scale. It's not like remote code execution and the entire world collapses, but still pretty bad. If you're ever coding a sudo binary, which you shouldn't, but if you are, drop your entire environment. And even if you do, notice here that even if you drop your entire environment, you can still plant like a .term info directory in your home like your home directory, which is still not great. So like be aware of those things, be aware of the environment that you're importing, and be aware of the dependencies that you have, because it's very hard sometimes to know, like you're importing a static or dynamic library, what are the implications? Sometimes it's not very clear, and there are security implications to that. And update your systems. Like if you're using Mac or Linux or whatnot, keep your system up to date, obviously. Next slide. And I think you guys can get 13 minutes back. Unless there are questions, I will be taking questions. See if I can zoom out here. I don't know how to zoom out. Let me turn around to the virtual audience. Silence is acceptance. And any questions from the room? Okay, everyone either got like all the technical details or got nothing. Either way, I'm happy. Thank you so much. Have a good one.
Well, thank you, JBO, for